Good morning, ladies and gentlemen. Let me introduce myself to you. My name is T. Connie, and I'm the moderator for today's webinar. On behalf of the organizer, I would like to welcome all of you to our Humanizing Innovation at MMU webinar series. Thank you for sparing us your time to be with us this morning. The title of our webinar today is, next slide, Practical AI Applications in the Real World. So this is the program flow for our program today. So we will start with the sharing session by Professor Dr. Tan Sing Chiang on AI history and applications in scholarly literature. And this is followed by the sharing session by Dr. Horn from MIMOS on AI applications from the industrial perspective. After that, we will have a dialogue session and a live chat session. So if you have any questions, feel free to post your question and we will answer with the panels during this live chat session. And lastly, we will end this seminar with a concluding remark. Next slide. Dr. Hon Hock Woon received his bachelor degree in Electrical and Electronic Engineering from the Nottingham Trent University, United Kingdom in 1997, and his doctorate degree in the same university in year 2000. Dr. Hon's main research interests are in computer vision and machine learning. Dr. Hon currently holds a position of Senior Principal Researcher at MIMOS Berhad. Dr. Hon holds a number of key patents in computer vision and image processing technologies. He is also a certified Six Sigma Black Belt as well as professional project manager. Dr. Tan Sing Chiang received his Bachelor of Technology and Master of Science degrees from University Science Malaysia in 1999 and 2002 respectively. And he obtained his PhD degree from Multimedia University in 2008. He is currently a professor with the Faculty of Information Science and Technology, Multimedia University. Professor Tan has published more than 100 research papers. His current research interests are computational intelligence and its application, which include but are not limited to data classification, condition monitoring, fault detection, and others. Professor Tan was a recipient of the Matsume International Foundation Fellowship, Japan. So without further ado, let us welcome Dr. Tan to give his talk. So Professor Tan, over to you.
Thank you, Dr. T. Good morning, everyone. My name is Tan Shin Chang. I'm an academic staff from the Faculty of Information Science and Technology, Multimedia University, Malacca campus. It's my great honor to join in this section to share with you all my knowledge about artificial intelligence. For information, artificial intelligence, or for short, AI, has grown to be very popular in today's world. In the following presentation, I will share what is AI and the history of AI. AI is an emerging technology, and it is bringing a great impact on our quality of life. In today's webinar, I will also share with you all some examples of AI application. Next slide. The intelligence demonstrated by machine is known as artificial intelligence. It is the simulation of natural intelligence in machines that are programmed to learn with experience and perform human-like tasks. There are three key components required to build an AI system. They are, first, computational system, second, AI algorithm, and third, database. Okay, for the first component, computational system, it is a system that will perform any of information processing that can be represented mathematically, that range from simple calculation to advanced calculation in AI. The second component, the AI algorithm, it is referred as a set of rules or a list of procedure to help AI to learn on its own. The third component, database. AI needs data to recognize patterns. Large datasets are required to effectively build and deploy AI systems. Today, AI technology is still at an infancy state. Its potential has yet been fully explored and shown. The more human-like the desired outcome, the more data and processing power will be required. For information, a long-term goal in AI research is to make computers to think and act like human. And it is a long milestone to achieve from now. Next slide. The idea of making inanimate objects as intelligent beings have been around since thousands of years ago. For example, the ancient Chinese engineers built automatons. What is automatons? Automatons are referred as the moving mechanical devices. AI is a branch from computer sciences that combines studies from different fields, which include, for example, mathematics, psychology, engineering, economics, and political sciences. The history of AI is not long, which was introduced formally in 1950s. Next slide. Okay, so the beginning of modern AI can be traced to the introduction of symbolic system by classical philosophers in 1940s, where these symbolic systems were built to describe human thinking. In year 1943, the first work that is now recognized as AI was introduced by Warren McCulloch and Walter Pitts, where an AI model called artificial neurons was proposed. In year 1950, Alan Turing, which was a famous English mathematician and a pioneer research in machine learning, introduced this Turing test. The test was applied to evaluate a machine ability in exhibiting intelligent behavior. Next slide. In year 1956, the field of AI was formally founded at a conference where the term artificial intelligence was mentioned for the first time. In year 1966, the first chatbot called Eliza was introduced. In 1972, the first intelligent humanoid robot called Robot 1 was introduced. Next slide. Sorry. Please turn back the slide before this. Okay. AI is made up by many fields. For example, fuzzy systems, expert system, natural language processing, image and speech recognition, machine learning, and deep learning. Okay. Machine learning is deemed as a subfield of deep learning is deemed as a subfield of machine learning. where the computing models in deep learning are extended from machine learning. Deep or machine learning are popular AI techniques nowadays. They could perform supervised learning, unsupervised learning, reinforcement learning, or evolutionary learning. A database could be defined by a set of input attributes that form an unlabeled dataset or a combination of both input and output attributes that form a labeled dataset. The main difference between supervised and unsupervised learning is that the use of labeled dataset. All supervised machine learning methods learn data structure or patterns from labeled dataset, whereas unsupervised machine learning methods learn data structure or patterns from unlabeled dataset. Reinforcement learning, on the other hand, is a machine learning method based on rewarding desired outcome and punishing undesired ones. Next slide. So, what AI can do for us? AI can be used to assist a human worker in performing tedious tasks. Okay. For information, tedious tasks are referred to as boring and repetitive tasks. In this case, AI can be used to guide, organize, and automate work for us. An example of the work is the application of AI as a voice or chat assistant, or we so-called as a chatbot. Okay. IBM has developed a voice integration tool, okay, that responds to queries needed to report using voice. This way, an enterprise can capitalize on integrating well with voice assistant that a consumer is getting used to. From a broad view, with the introduction of AI assistant, executives in a company should be helping to reduce jobs in which AI and machine learning take over boring tasks, while humans spend more time with high-level tasks. Okay, next slide. Okay, so another use of AI is in this big data era. AI also can be applied to perform data analytics or so-called business intelligence. AI can be applied to discover insights, to find new patterns and discover relationships in the data and transform the data into useful knowledge for decision support or for decision making. In practice, AI analytics is the process of automating much of the work that a data analyst would normally perform. Next slide. Okay. The application of AI based on the report from research articles is far reaching. AI has been applied in a wide range of industry domains. For example, from manufacturing to power industry, from finance to agriculture and healthcare. Okay. And then AI are also applied in computer vision, natural language processing, speech and signal processing, for example. Next slide. Okay, so this slide shows the examples of AI application that in agriculture that are reported in the literature, which include the application of machine learning for estimating yield performance of corn hybrid. Corn here, we may, another term to corn is maize. Corn hybrid, for information, corn hybrids are the new seed created by crossing two parents together to obtain a stronger and more productive seed. And machine learning in this work is uh, is applied to estimate the yield performance of these corn hybrids. Okay. AI has been also applied to perform pineapple fruit recognition, where pineapple images are processed using image processing techniques, and the number of pineapples is counted using artificial neural networks. In another two examples of AI application, deep learning is applied to perform plant disease detection and crop insect detection. Next slide. Okay. This slide shows 4 application examples of AI in healthcare. In these AI applications, machine learning has been applied to perform disease prediction for skin cancer and also to predict depressive symptoms among the elderly. Machine learning has been proposed to tackle public health problems in a society such as obesity, as well as to perform fraud detection in the healthcare insurance business. Okay. Next slide. That's all my sharing with you today. I'll now pass the time back to Dr. T. Thank you.
Okay, so thanks, Prof. Tan, for your insightful sharing. So now let us welcome Dr. Horn. Okay, so Dr. Horn will share with us his experience about using AI from the industrial perspective. So, Dr. Horn, over to you.
Okay. Thank you, Dr. T. Good morning, everyone. First of all, I'd like to express my gratitude to MMU, Prof. Tan, Dr. T, Dr. Koo, Ruzi, and all who have contributed to this event. So my name is Dr. Hon Hock Wood. I'm a senior principal researcher from Mimos Berhad. So in these sessions, I'll be sharing some of the work and experience in implementing AI applications in practical environments. So in fact, the scope of AI is quite huge and it covers many areas. So I'm more of a computer vision person, and in these sessions, I'll be using computer vision as an example. So I put together some pictures from the previous works and we'll go through the challenges we encounter, and also we'll do some sharing on our best practices. So I hope the content is useful to the audience and I can make some contribution to the community by sharing this experience. Okay, can we go to the next slide? Okay, so this is what we are going to do for the next 15 to 20 minutes. So I'll start off with the common understanding of AI components. So in this case, these are data, models, and compute. Then we follow up with some challenges and considerations in practical AI applications. So then the next item would be some selected example of AI deployments that we have done so far. Okay, can we go to the next slide, please? So before we move on to the AI components, let me give you some backgrounds of some of the AI works that we have involved in over the years. So as you can see, there are 3 areas here. So most of our applications requires real-time streaming of video data. So in this case, on top of the accuracy, processing time is also a key factor to ensure the success of the process. So in the first area here, it says intelligence surveillance. So this is mainly used for security purposes. For example, smart cities applications like intrusion detection and loitering detections. So we have implemented this in a number of places, including ports and detention center in Malaysia. So basically what it does is it detects strange and abnormal human behavior. So we model the person movement and trying to understand what they are doing in that environment. So the second areas we have involved in is visual inspection. This is more of a use in manufacturing sector to improve the productivity by detecting the defects. So we are looking at AI techniques that are more efficient in detecting 3D and more complex objects. So the next area we have looked at is AI-based transportation and traffic analytics. So we have done quite a bit of work in this area in some of our projects. So this include the vehicle identifications, number plate recognitions, vehicle counting at complex junctions, and vehicle classification on the route. So today, due to the constraint of the time, I'll be using transportation as an example to further explain the words. So the AI principle behind is almost the same. It can be used across other areas. So can we go to the next slide? So let's take a look at this AI component. So in a broad sense, AI can be commonly categorized into three main components. So the first one is data, then models and compute. So for data, we need data for training and do the inferencing to predict the result. So common data types are, as you can see from the slide here, are images, streaming videos, documents, text, speech, sensor, time series data. So for model, there are many model zoos and toolkits available on the web. So for example, Keras application model, TensorFlow, PyTorch model zoo, you can find them easily from the web. So, or you can also train your model from the readily available cloud services like AWS, GCP from Google's, and Azure Cloud from Microsoft. So the third item here is the compute. So it can be in a different form of hardware. So as you can see, it can be on a desktop, can be on a server, can be on the cloud, or even on chip. So example of compute devices are CPU, TPUs, and GPU. So let's next slide, please. Next slide, please. So as mentioned earlier, there are multiple ways to get open data sets. So we can download the open data set from various places like ImageNet, Kaggle, UCI websites. So what I'm trying to emphasize here is the specific data sets, the one on the green, that you may not be able to get easily from public domain. So this is either due to the localization of system, or this is in a very niche area. So you probably have to design and generate your own primary data. So for example, you can see the pictures on the right-hand side, the X-ray inspection for 3D structures or industrial signal for acoustic and optical. So for this kind of data, you most likely you won't be able to get any open data set for this. So when we first look at the vehicle identification application 5 years ago, so that's if you refer to the picture second column, so there are some open data set for number plate recognitions. So it was good for a kickstart. So as we are dealing with more and more specific feature, the system breaks down and unable to handle the requirements. So in the end, we had to generate our own data set for accuracy localization for Malaysia plates. So next slide, please. So in this vehicle identifications, we use a number plates as a unique ID for the car. So this is, if you look at the slide here on the left-hand side, this is a standard number plates that we normally see on the roads. So they are standardized. So when I say standardized, I mean the font size, the font types, and even the gap between the alphabet and numbers are all predefined. So in Malaysia, we have the standardization and guidelines from JPJ, but I think not everyone following it strictly. So next slide, please. So in practical environment, we have to deal with various types of noises. So this include the non-compliant or illegal plates. So this includes the cursive plates, small size plates, and there's no gap in between the numbers, and also includes some of the broken plates. So the other factor is lighting conditions, day, night, evening, raining, or other weather conditions. It makes the image look very different. The other constraint that we have is physical constraints to place the sensors or to place the camera. This is used to capture the data. Let's take a look at some of the example images, then you would probably appreciate more what I'm talking about here. I think we all show in the next slide. Okay, thank you. On the actual sites, you will see different problems, especially when we are dealing with a system that runs 24/7. So this is running 24 hours, 7 days. So if we look at the example, these are the 4 standard plates from 4 different countries. Malaysia, the first one for Malaysia, second Singapore, Thailand, and Myanmar. So these are standard number plates. So they look standardized and good, mentioned earlier, but not all the plates on the roads look like this. So can you click once? So if you look at the vehicles on the roads, you'll see there are all different types of plates. They're not really standardized. You can see cursive plates, and also, so on the left-hand side, you can see there's a foreign object, the emblem, foreign objects for RJ78. So these are actually creating noise for the license plate recognition's algorithm. So can you click one more time? So there are also broken and dirty plates on the road. And the plates also form funny words. If you look at the picture that says NAJ113, it actually reads as Najib. So can you click one more time? So for taxi plates, it is inverse in background and foreground. So the foreground is black. So in certain province in Myanmar, we get some we notice that there are some backgrounds in different colors, red and yellow. So the Thai plate usually is quite clean, but recently we have also observed some of the colorful background. So this non-compliant plates actually makes the number plate recognition very complex in certain countries. Okay, next slide, please. So let's take a look at the lighting condition. So if you look at the first light, this is at night, at low light conditions. All numbers, if you can see, all numbers are stick together. So it's very difficult to differentiate the number. So on the second picture, the headlamp shines directly to the cameras and it blinds the camera view. So these are another constraints. Image number 3 is an abrupt change of light. Usually this happens in the entrance at the shopping mall and shopping mall car parks. So of course, next is the different weather conditions. You can see it's a glaring in the morning, mist after the rain, stay on the lens, and also during the rain. So all of this create a complexity in terms of the data. And AI is a best solution to handle this kind of complexity. So we managed to solve most of them, and some remain unsolved up to this point. So can you move to the next slide? Let's take a look at some of the physical constraints. This is related to where we can place the camera or sensor between the target objects. So if you look at the first one, this is I think this is at the highway. So the only place we can put the cameras is at the overbridge. So the problem with this is the plate will look tilted vertically. So on the second image is a tilted view from the car park on the petrol car. So the cameras is on top of the car. So the view is tilted. So with all of this, that we have to do pre-processing to do correction before we can process or use the data. So of course, the third one is a narrow parking lot. There's very little things we can do about it. We could actually only see the first car. So with all these views, we have to do pre-processing and also post-processing in order to make full use of the data. So the other one is the ad hoc checkpoint set up by the police. If you look at the last image there. So the angle of views that also complicate the models that you have created. So common place of deploying this is are like highway, petrol station, and car park. So here we are going to look at the challenges in the model. You can go to the next slide, please. Okay, there are many ways to get to the model. For example, from the Keras model zoo, TensorFlow models. So as I mentioned earlier, and there are also many models ready to use. So with the existing model, it helps to reduce the development time. Another way is to use a pre-trained model. So usually what we do is we look at any pre-trained models available first. So if it's available, we'll use it. And if it's not suitable, then we'll do a transfer learning to enhance the features. So if we are really unable to do it, then to find any suitable model, then we have to create a model from scratch. And this is a very costly and resource intensive. So next slide, please. So when we are choosing the models, we need to consider the balance and trade-off between the accuracy requirement and the inference time. So some also refer to processing time. So if you look at the diagram here, the inference time and accuracy is inversely proportional. So meaning you have to choose one over another to achieve the best trade-off based on your requirement. So can you move to the next slide, please? So let me give you one example where model plays a very important role. So even though the models can provide very high accuracy, but it is not adopted by the industry as it can't make the inference time requirement. So this is for the defect detection in manufacturing line. So usually the template matching is very good for detection logical problem. However, if the problem as the problem become complex and is ambiguous in terms of the detections, so AI would be a good technique to address this problem. So as I mentioned earlier, even though there are AI solutions available in the market, but the adoption rate is very low. So one of the reasons is the inference time requirement cannot be met by most of the system. So in this case that we have to either use super hardware, but usually it fails the cost and benefit analysis, or we improve the algorithms or improve the model. So this shows us the models and process planning is very important. So can you, next slide please. So our common practice is, this is what we normally do. We use supervised learning to have more control on the models. And also we keep the model as simple as possible and task specific. So we also design it in such a way that it's modular and debuggable. So it may not necessarily be the traditional complex model design. And we also try to make it flexible where it can run on different hardware, so with and without GPU. So this is normally what we do when we design a system. So can you move to the next slide, please? Okay, so now you have a model, and these are the scenes that you have to deal with using the same model. So it's kind of painful to look at these images, but this is in the real environment. For example, the same scene at different hours, the shadow cast at different angle, and it looks very noisy. And the big object size variations are very different at different point in distance. Then also bad weather makes it even more complex. But these are the image data that we have to deal with. So AI is a good solution, provide a good solution to address these problems. So next slide, please. So another challenge is similarity in classes. So this is a KKR standard for vehicle classifications. So there are 6 different classes in total. So we have to follow the standard. Like for example, C1 is a car, taxi, small MPV. Then C6 is a motorcycle and scooter. So the challenge here is intra-class similarity. If you look at the challenges on the C4 on the right-hand side. Okay, for the similar, the object looks very different. You can see, but they are grouped under the same class. So the other challenge is the high interclass similarity, where there are 2 different classes, C1 and C2, but the objects or the vehicle looks very similar. So for example, Perodua Alza, there's a lot of confusions on this, whether it's a car or it's an MPV. So the answer for the KKR is considered a car, even though it's classified as MPV. Yes. Now, can you move on to the next slide? So now we have come to the last component, which is the compute. So these are some of the important hardware that we are looking at for training and inference. So we are still exploring this, how to maximize the use of compute hardware. The list is not exhaustive. This is what we put together, where these are the hardware that we are looking at, basically for training and inference. Also, the selection of hardware is also much depending on the software framework chosen. Okay, move to the next slide. So these are some of the compute hardware we are looking at, from microcontrollers, edge machine to the cloud. Depending on the application complexity, we use different hardware. Okay, next slide, please. Okay, let me share with you some of the selected application that we have deployed. So we work with auto parking machine manufacturer to tie AI analytics to the ticketing machine. The second one is detecting the car that never pay their parking tickets in KL. So this is a petrol car that go around and look for those cars that's never paid for the parking ticket. So it's already enforced and in use. The column number 3 is a petrol station payment made by recognizing the number plates and some properties of the vehicle. So when they pump the petrol, the bill will go directly to their credit cards. So the two images you see here, they are from Singapore and Thailand. Okay, next slide. So this is my last slide. So up to this point, I think we have successfully implemented practical AI in computer vision area. So we have done quite a number of deployments for various AI applications, and also we have piloted this in 4 different countries. Another point is we received Asia Pacific ICT Award 2 years in a row for the industry application in AI technology category. So I think by carefully designing the 3 AI components, which is data, model, and compute, it is possible to make AI works in practical applications. Okay, that's all from me. Thank you very much.
All right. So thanks, Dr. Hon, for your interesting sharing. So it's actually very interesting to know the real world actually looks so different from what we have been imagining all this while. Yeah, especially the different types of car, the different types of vehicles that we have on the public road. Yeah. So yeah, thanks for the interesting sharing. Yeah.
Sure.
Yeah. So
Fine.
now it's time for us to move on to the Q&A session. So to the members of the floor, if you have any questions, feel free to post your questions and we will answer your question during this Q&A sharing. All right. So meanwhile, I have a question to you. All right. So we know that in an AI applications, data plays a very important role. All right. So may I know how usually you perform data collection at your site? So maybe Prof. Tan, from your perspective from the research world, and how about you, Dr. Hon, from the industrial world? Yeah. So maybe we start from Prof. Tan first, from the research world, how you usually perform data collection.
Okay, thank you, Dr. Connie, Dr. T. Um, I think this is actually a great challenge in AI research because, as you know, that data is very important. Of course, another factor that we consider is the suitability of the AI model. But before this, we need to ensure the data that we have, that we collected, is useful to tackle the problem. And let me share with you my experience. When I was a master student, yes, I my study is about condition monitoring on the one of the system in a power generation station. So as a student, I have no knowledge about the uh, the operating condition in that station. So what I did is I need to consult the engineers, and consult the engineers and consult the supervisors to learn in more detail about the uh, the the system before I identify uh, what kind of data that I shall collect from. And also, I need to understand what problem they are facing. Only then, I through this a number of discussion and also sharing with them, and they also like to know what is my intention, right? Because they have no clue uh, why I need to use data because that time maybe 20 years ago, right? So they have no idea why I need data, but that is how we need to communicate, and then this is how we communicate, and then uh, collect, and then I managed to collect the right data from them after consulting them. And this data, the data that I have is actually, it's not only the record, it's not only the numeric record, but also it blends some of the working experience from the engineers there, and also the practice, and also working practice there. Yeah, thank
All
you.
right. Yeah. So it seems it's not easy, huh, to perform data collection. Yeah.
Yes.
Mm-hmm. All right. Then, Dr. Hon, how about you? Yeah. How usually you tackle such a situation? Yeah, from your perspective. Yeah.
So from the industry, so usually normally what we do is first we sit down and think of what data to collect first. Then we look at the open data sets from the web. So if it's available, that we will use the open data set. So if it's not available, then we will take a different approach. So we look for some of the pre-trained model that's already trained up with the data. So if it's suitable, then we will use it. So we don't want to reinvent the wheel. So we have to acknowledge the credit to the pre-trained models and we can use it directly. So if it's not quite suitable, and it requires some enhancement. So one way of doing this is we do transfer learning to enhance certain features. So if this is for more of a general problems, if we are dealing with a very specific problems, then all of these are not probably most likely not really possible. So we have no choice but to collect our own data. So it's actually interesting. It's interesting to collect our own data. I mean the primary data. So we get exactly what you need. So you can design the data. So for example, if you have a sensor, where to place the sensors, where to place the cameras, where to capture the data, the angle of view, the field of view. So you can design the data. But to collect primary data is actually come with a cost, so which is very time and resources consuming, very intensive, basically. So you may also face, depends on what data that we are collecting. So you may also need permission from the authority to collect the data. For example, if you want to collect data from the highway or on the street, that you may need permissions from DPKL, and also for highway you need to get the permission from LLN, so Lembaga Lebuh Malaysia. So of course, another ways to increase more data is we use augmentation, the quite standard augmentations where we flip, we zoom, and crop data, but the effect doesn't really help much. So this is what we do for the data collection when we run the project.
Okay. All right. So how about now? Let's say you are given a new problem. So how you usually approach the problem, let's say from the beginning, from problem statement until the very end of the AI solution, the end-to-end solution. So how usually you approach a new problem, yeah, given to you. Yeah, so maybe Prof Tan, maybe, yeah, how you approach a problem, an AI problem from the research perspective. Yeah, from the beginning until the end. Yeah.
Um, okay, thank you, Dr. T. I will see this from two perspectives. To tackle the same problem, but we have different practices. The first practice is, let's say, if we were to make a benchmark study, I mean, to compare the performance of a newly developed AI solution, we may refer to those public data from that are available in the over the internet, and then that is how we because the problem is pretty I mean is well known. Then we know whether it is a kind of a classification, either it's a kind of classification problem, a regression problem, or optimization problem. We need to we know all these kind of problem. Then from there we refer to the data set that we that the problem when this data set is available. Then we develop the AI solution, and then we perform the benchmark study with the public data set. Okay, in the second practice, let's say if it is uh, I mean the practical data is a practical research. Let's say in this case, after getting the consent by the company, okay, we have an interview with the staff in the company to understand what is the problem that they are facing. So uh, and then from there we try to find out what are the challenge, understand the challenges that they face, and also we also learn the constraint or the limitation that they encounter. From there, after considering all these constraints and the resources available, we formulate, we work together to formulate I mean, to define a problem, that can be where this problem can be solved using AI approach, because not all problem can be solved using the AI approach. So one of the key idea to solve this, one of the requirement to solve this problem using the AI approach is that we need to define what data set to use, and what are the features to be considered to form the data set. And then we also need to identify whether it is a classification problem, whether it is a optimization problem, or is a regression problem, or is not or is a prediction. Is a prediction. So I think these are the the crew. These are the guideline that we we will refer before we formulate a solution for the problem.
All right. So thanks, Prof. Tan. Then how about you, Dr. Hon? So usually, how do you approach a new AI problem? Yeah. Dr. Hon, made you unmute your microphone. Yeah. Okay. Yeah, we can hear you now. Yes.
So when there's a new problem given to us, I think first thing we'll do is to understand the problems and also break it down into a smaller parts of the problems. So we will separate them into logical problems, engineering problems, or which is AI problems. So we'll separate them into the different buckets. For logical problem and engineering problem, we will leave them aside. Then I think we know how to solve the engineering problems. For AI problems specifically, I think for this discussion is on the AI problems. So we will make sure that we have enough right data. So when I say right data, I mean the data has a good coverage and populations. I mean it's cover most of the population of the data. Okay. Then after that, we will evaluate the models, like what Prof. Tan mentioned just now, whether what kind of models that we need to use, whether it's a classification model, it's a regression model, or it's the prediction model. So then we create a model, like what I mentioned in my earlier presentations. We'll keep the model as simple as possible, simple and specific. So for example, we usually use for example classifications. We use usually start with two classes. So we don't start with the multi class. Then it will actually complicate the problems. So we also make sure that the models can meet the processing time and accuracy requirement by the as specified by the problems. So then we'll come up with a system flow. After we've done that, we come up with the system flows, and we actually design the flow in such a way that is flexible enough to take in the traditional machine learning, deep learning, and also some of the pattern recognition, image processing method. So it's a actual mixture. It's a kind of a hybrid model. So instead of a single machine learning model or a deep learning model, so as well as we have to make it sustainable and upgradable. So let's say the user wants it today. So tomorrow, if the system is good, they will need to do upgrade or scale it up to a higher performance. So we have to bear this in mind when we are doing the design and approaching the problems. So then after we have these models and data, it comes to the choosing the what compute that we need, what kind of machines that is suitable. So within the we don't want to overuse it or we want to underuse the machine. So once we have that, then we will do some we put in the test staging and do optimization of it before we deploy the solutions. In the market. In the field. I'm sorry, it should be in the field. So this is my or our approach when we handle problems from end to end.
Okay, yeah, all right. So actually, we are having a series of questions from members of the floor. So, okay, we have Mr. Hazero. So he's asking, how do we know that we have actually achieved the required accuracy or the acceptable accuracy for an AI problem? Yeah, so maybe Mr. Hazero is working on an AI problem. So he's asking how much accuracy I must achieve to be accurate enough. Yeah, so I think this is the main point he's asking. How accurate is accurate? Yeah. So maybe Prof. Tan, you want to start from your academic point of view, how accurate is accurate? Yeah, then
Okay,
industrial,
thank
how about it? Yeah, Prof. Tan.
thank you, thank you, Dr. Kani. Yeah, intuitively, the higher the better. I mean, the higher accuracy, the better. But sometimes we face a situation that this accuracy cannot be longer further improved. Because if you refer to the real data set, it cannot be further improved. In this condition, I would suggest maybe we look what additional attribute that we can consider to include to make the data more complete. Hopefully, it can help the machine can be useful to detect and perform to perform with higher accuracy performance. Yeah, that is my viewpoint.
All
Over to
right.
you, Dr. T.
Yeah. So how about you, Dr. Hon? Yeah. How
Uh,
do you view this? Yeah.
so I think it's very much depends on the application. So for example, if you are for example, in the application for the toll gate, uh, in the highway collecting the fee. So the accuracy has to be very accurate because it involves some transaction. So if there's some error, there's actually cause a lot of problems, a lot of disputes. So like for example, in a highway, usually there are about 20,000 cars. So if your accuracy is 99%, so it will still not be good enough for the operators because there'll be 200 car that is the errors every day. So these 200 cars, the problem is this 200 car is embedded within the 20,000. You don't even know which car has the problems. So whereas I mean, in this case, this is very critical to have a very high accuracy. So on the other hand, if you have binary classifications to detect whether it's a kid or whether it's a adult, or whether it's male or female. So in this case, that the accuracy, I think it can be slightly lower because you are making a threshold between the kids and adult. So as long as it hit a certain threshold level, so you can call it class A or class B. Okay. So of course, traditionally to improve the accuracy is training more, giving it more data to train. Yeah.
Yeah, so actually we have one question from Professor Hezero. So Professor Hezero is asking, how much data set is actually enough for an AI problem? So Professor Hezero is, in fact, I think he's working on a durian counting system. So yeah, so he says he want to detect and count the number of durian. So in his case, so how much data is sufficient? Yeah. So maybe Prof. Tan, yeah, what is your view on this? Yeah.
Okay, I view this from the academic research perspective. Uh, uh, let's say there is a guideline, but it may not be true that the number of data because in computer science we have a term called as the curse of dimensionality. The curse of dimensionality. Under this, the curse of dimensionality is state that if you have addition more attribute or more dimension of the data, of the attribute, then the more data is required, and then how much it is required. I mean, how much is sufficient? Actually, that is a mathematical formulation as a mathematical formula to serve as a guideline, and then this is from the theoretical perspective. Yeah, but of course, in the real situation is that we may face even though we have uh, I mean a great we managed to collect uh, high volume of data. The next challenge to meet is the processing time. The processing time. With the when we analyze this data with the AI techniques. But as I said just now, we may refer to a formula that would suggest the number of data to be to be collected. Thank you.
So thanks, Prof. Tan, for your view. And how about Dr. Hon? Yeah, what is your opinion towards this? Yeah, the size of the data set. Yeah.
So I think this is a very popular question. Uh, so I mean, in my view, the key factor would be the how similar is the object that you want to differentiate. So let's take an example for classifications. So let's say if your class that you want to differentiate them, one is dog, the other one is cat, then you can live with a relatively smaller number of data sets. So, but if you are doing classification on a car model, say for example Honda City, Honda Civic, and Honda Accord, so they looks very similar because it has a family outlook. So in this case, that since all three classes they are very similar, then you need more data to it. So for the first case that I mentioned earlier, like dog and cat, or some of the object class that you want to detect is very different, red bean and green bean, then I think you can leave it as small as that. This is our opinion, our experience. So you can leave it as low as maybe 200 data set. So for the other one that I mentioned with a very similar class similarity, object class similarity, that it can go to as the number can go very high. So at least you're looking at in the thousand or tens of thousands of data set. Okay, this is my opinion.
All right. So thanks, Dr. Hon, for your answer. And then now we have another question from quite different perspective. Yeah. So this is a question from Mr. Timilihin. So Mr. Timilihin says, thank you, Dr. Hon and Dr. Tan, for the interesting and educative sessions. Okay. So his question for you is, he actually direct his questions to Dr. Hon. So he's asking, I would like to ask if there is any existing opportunity for recent PhD graduates who wish to gain practical AI experience at research institutes like MOS. So yeah, he's asking about this. Yeah, the opportunities for postdoc position. Yeah. So he's directing the question to you, Dr. Hon. Yeah.
Okay, sure. I think we always think that there are a lot of talented people in the university And we also constantly look out for talents in university and other research institutions. So actually for the questions about the research sorry, what is research as placement? Is it the research placement?
Yes.
So I think there are some opportunity. I think in the past we used to hire research assistant and research officer. So where they spend their time while doing their PhD, they are working on the projects in MIMOS. I think it's supervised by the university and co-supervised by one of the staff from MIMOS perhaps. So in this case that they are doing the similar topic in the university and also work on the similar problems. So this is one of the way that it's how we link up the university students in the industry. So there's apart from that, there's also internship, but internship is a relatively shorter time. So I think it's about 5 months. But I think this is mostly for the undergrad student.
Yeah, so I think his question is he is going to graduate soon. He's going to finish his PhD soon. So is there any research opportunities? Yeah, yeah,
Yeah, yeah,
graduating. Yeah.
sure. So I think currently I'm heading the AI department in MIMOS. So if you are interested to join us, as I mentioned earlier, we are constantly look out for talents. Maybe please send me your CV and then let's have a chat about this.
All right. Thanks.
Yeah, the short answer is yeah, that is.
Yes. Thanks,
Yes.
Dr. Hon, for giving our students the opportunity. Yeah. Thank you. All right. So I'm wondering, yeah, coming back to our technical part, the questions. Yeah. So I'm wondering, usually when you have completed a AI problem, so what is your expectation, yeah, from your research project? Yeah. So maybe Prof. Tan, let's say you have completed an AI project. So what is your expectation, yeah, from your output? Yeah. Then how about the industrial world? After you finish a project, what do you expect, yeah, from the outcome? Yeah, maybe Prof. Tan? Yeah.
Okay, thank you, Dr. T. Yeah, okay, to answer your question, the main expectation or the output from the research project is the paper publication, which includes, let's say, journal papers, book chapters, conference papers, or book, okay, or monograph. And then, of course, it's not limited to this scholarly paper publication. We may also aim, let's say, patents or copyright. Yeah. Over to you, Dr. T.
All right. So thanks, Prof. Tan. So apart from paper publication, so what industry are looking at, Dr. Hon?
So to answer the same questions, the first thing that we must make sure whatever solutions that we come up with meet the customer requirement. So in terms of processing time and accuracy. So we will make sure the system or the AI system is scalable to a higher demand. So in terms of sizing and upgradability. So uh, so we don't have to go back to the customer to look for more data. So in terms of the output for industry, patents and copyrights are important to us. So once we file a patent, there's about 18 months of grace period for us to do paper publications. So we do publication as well, but patent is in a higher priority compared to paper publications.
All right. Okay. So coming up next, we have another questions from the audience. So we have a questions from Jessica. So Jessica is asking. So Jessica say, okay, thank you for the great sessions. I have a question for Dr. Hon. Okay. So she's asking because data is very important for AI. However, there will be cases where the data are hard to obtain or limited. Okay, so for this case, when AI will need to be implemented, then there might be problem due to the limited data available. So, Dr. Hon, can you give some advice from the industrial point of view? How can we overcome this problem? So currently, Jessica is working for credit scoring for risk analysis and also prediction. So we are actually facing a trouble with finding enough data. So can you advise on this, Dr. Hon?
Okay. So when you have a small data set, and I think one of the things is to do augmentation to get the different variants of the small data set that you have. But I think the effect is not so may not be so significant because the sources come from the same data. So the other way is to probably look at the dimensionality reduction technique like PCA and TSNA. So we see how we can then get the principal components for you use the principal component analysis to get the to uh, right, to enhance the small data set that you have. So basically, with small number of data set that is actually is quite difficult. You can do something, but the result is not guaranteed.
All right. Okay. So yeah, I hope Dr. Han,
Yeah, I'm not sure whether I answered the
Yes,
question.
Jessica question. Yes. Yeah. So anyway, from our conversation just now, I find that there is some difference lah, some gaps between the academic world and the industrial world. Yeah, especially the expectation about the research outcome and things like that. So I'm wondering, in your opinion, what do you think can be done to bridge the gap, yeah, to fill the alignment, yeah, between the industrial world and also the academic world? Yeah. So maybe Prof. Tan, yeah, what is your opinion towards this? Yeah, bridging the gaps between two worlds.
Okay, thank you, Dr. T. To bridge the gap between the industry and academia, I think one of the, uh, I mean, we need some kind of collaboration. Need some kind of collaboration, and then, for example, let's say university staff. University staff in in the university, most of the academic staff may have no industrial experience. So uh, it is a good option if the staff is given an opportunity to join in. To take industrial leave to work in a company for a short duration, so that the staff is upgraded with the new expectation and also learn new skill. Yeah.
All right. So how
And
about you? Yeah. Oh, sorry. Yeah, Prof. Tan. Yeah, you
sorry,
want
sorry.
to yeah
Yeah.
interrupt?
So and
Yeah.
this is for the staff. Let's say I mean this is the same for the undergraduate student. In order to get a greater exposure before graduation, it's better if the student have an opportunity, not necessarily during the internship, maybe during the semester break time before the final year. If the student manage to take the initiative to apply and then do a temporary job in a company, that will be also a kind of exposure for the student before they join at the new workforce in the market after they graduate later on. Yeah.
Yeah. So some initiatives might be coming from the student itself.
Yeah, and also there is another possible collaboration between the industry and academic is that some postgraduate study that can be jointly supervised by supervisor from industry, from the company, and also the university. Yeah, that is all my opinions. Over to you,
Okay.
Dr. Connie.
All right. Thanks, Prof. Tan. Then what is your view? Yeah, Dr. Hon.
Uh, so from the industry, we are actually the receiving end from the product from the university. So which is the graduates and also postgraduates. So, we do hire some fresh graduate before. So I think most of them they are good. They understand the techniques. They know all the essential skills like math, statistic, and probability. So they understand it, and they are mostly they are. I mean, for the young generation, actually, they are quite good at how to find the data, how to run the AI tests. But I think one things that will take some time to have some learning curve is when they deal with specific problems. So I think I mean they have read probably read a lot of AI related materials and also exposure to the AI world. So I think for the students, they can before they graduate, if like what the Prof Tan mentioned just now, the industry trainings, internship, and also the research officer for the postgraduate, that would be helpful to the students before they graduate. So that once they have graduated, then there will be no gap in between. I mean, the transition from university to industry, that would be very smooth. So for academic staff, uh, so we are also constantly looking at SME, the subject matter expert in AIs, in computer vision, NLP for consultancy is one way. The other mode of engagement could be right what Prof Tan mentioned just now, so sabbatical leave or collaboration in terms of research attachment. So I think most of the points that Dr. Tan has already elaborated. So I agree very much with what Prof. Tan mentioned just now.
All right. Okay. So thanks, Dr. Hon. All right. So we are now drawing very near to the end of the session today. So before we end our session, so may I have your advice to our audience who is maybe new to AI or who is going to venture into the into the area of AI, or who is going to further venturing into the AI field. So what is your advice to them? Yeah. So Prof. Tan?
Okay. Thank you, Dr. T. Um, my advice. Okay. Let's say if you are a undergraduate student, I think that you should try to grab the opportunity while you're a student in the university to learn more. Uh, I mean, to take your own initiative to learn more about AI techniques, to explore more. And for information, AI is one of the computing trend that will continue to evolve. So if if good, if you have the passion uh, uh, to uh, to study AI and and improve yourself uh, over the time. Yeah.
All right. So, Dr. Hon, yeah, any advice? Yeah, for our audience?
So for me, my advice is be a hands-on person and get your hand dirty and try it out. So there are many resources on the web like GitHub, like Kaggle, that let's go and try it out and some of the algorithms. And also when you try out, document your tests and result so you can refer back to it. And also, this is a personal experience. So you supervised learning. Start with supervised learning. Although a lot of people tell you that supervised is already outdated, but a lot of people tempted to use unsupervised learning or semi-supervised because it looks more like a AI solutions. But when you first get started, please look at the supervised learning first, understand it before you move to the other method, and keep things simple. Like what I mentioned earlier, if you're looking at the classifications, start with 2 classes. Then when it works, then only you move on to the multiple classes. And another things that I can think of is when you have the hyperparameters, when you do your test, you need to fine tune your hyperparameters. So try to fine tune it and see the effect on see the effect after you fine tune it. Do it manually. So before you move on to the automated fine tune like generic algorithms. So basically, is be my advice is be hands on.
All right. So, thank you very much for your advice. All right. So, we are already at the end of our session today. So before we end our webinar, all right, I would like to thank again Professor Tan and Dr. Horn for taking your time with us this morning. And also we would like to thank the chairperson of CUCC, Dr. Pang from Faculty of Information Science and Technology, and also the organizer of this webinar, which is the Industrial Collaborations and Engagement Center, ICEC, and also Research Industrial Collaboration and Engagement, RISE Division. And not forgetting the Strategic Marketing, Admission and Recruitment Smart Division, MMU Studio, and the technical support team for making this webinar conducted smoothly. All right. Then last but not least, thank you for all members of the floors. Okay, thanks for our audience for making time with us today. So, all right, every one of us take care and stay safe. So have a nice day. So hope to see you again in the future. Thank you and see you again. Bye.
Multimedia University, because MMU is you, leading the digital future. Visit mmu.edu.my.